Oops, sorry. Alright. So we have, what is a molar mass of sodium hydroxide? So, molar mass of sodium hydroxide. Now, the reason why I actually picked this question is for us to get familiar with the nomenclature, actually. Because the molar mass part is relatively straightforward in terms of finding it out, but it becomes increasingly difficult when you don't know what that name means in regards to molecular structure. So let's break it down. Okay, I like to draw a line right there, okay, just because it usually separates and distinguishes what type of molecule you have. So we have a sodium and a hydroxide, okay? So hydroxide, that's the one you kind of have to memorize, and we did briefly discuss it actually. So it is hydroxide, that's good. But if you remember, hydroxyl groups are just the OH. That's also what hydroxide is. It's just an OH minus, as we discussed earlier actually, right? And if you see the constituents of OH minus, that's just two nonmetals paired together, okay? And the reason why I mentioned that they're two nonmetals paired together is because remember the rules of ionic compound. So we know right now hydroxide is not ionic, it's just a molecular compound. But sodium is just Na, okay? Now, with that, it is a metal, okay? And now we want to make sure that we actually have the right amounts of electrons it likes to give away. So with this, you can either find it through its electron configuration to really understand it, or you can just use a periodic table and see that it's in the first column, okay? Elements in the first column like to typically just give away one electron, okay? So it'd be Na plus. If you wanted to use the method of blank on the electron configuration, you just start with neon, and you'd notice that right away all the sodium has will be 3s1, and that one there tells that that's the only valence electron it can give away. And the reason why it gives it away is because to get 7 more electrons to fill its shell will be so much effort, it'd rather just give away one to become an octet. So with that being said, there's one positive sodium and one negative hydroxide. So to balance it out, all you need really is to just go 1-to-1 ratio. So this will just be NaOH. That is sodium hydroxide. So once again, this is an ionic compound because that's a metal and a non-metal. So metal and non-metal, okay? And now that we know what sodium hydroxide is, let's find the molar mass. So that one, as I said, is relatively straightforward. You just have to count your constituents. So 1 Na, 1 O, 1 H. Okay? And sodium is 22.9. Okay. Oxygen is 15.999, and hydrogen is 1.008. Okay? And because it's just multiplied by 1, I just like to rewrite it on the side to keep things consistent. 999 1.008 8 plus 15.999 plus 22.90. You have in total 39.907. So yes, the molar mass of sodium hydroxide is 907 grams per mole. Just gotta draw that better. That right there should be the answer. So let's see here. Yep, they rounded a little bit different than I did, based on, I guess, the periodic table as well. Oh, did I really put, I missed a 990. That does change the answer just a slight bit. Let me see here what I get when I include the extra 0.9. Oh, okay. So I can see how they got 40. It's quite close to 40. Yeah, very close to 40. But yeah, so that's how you solve that question here. The trickiest part is knowing what sodium hydroxide is. Now, that was just a pretty much extra step, because sometimes they do just give you that information saying, hey, this is sodium hydroxide. Solve, go ahead and solve it. But sometimes when you're just given the name of the compound, it's important to just recognize how to separate and break it down to be able to get, the actual molecule. So with that, let's move on to question 5.